Alright, question 14 of the exam style questions in the polynomial section. The equation 2x cubed minus x squared plus 2x minus 3 equals 0 has roots alpha, beta, and gamma. Hence or otherwise find a cubic equation with roots alpha squared, beta squared, gamma squared. No problem. We know that sum of alpha is equal to negative 1 over 2, so that will be positive 1 over 2. We know that the sum of any two of them multiplied together is equal to positive 2 over 2, so that will be 1. And we know that alpha, beta, gamma is equal to just negative 3, so that will be positive 3. Whoops, nope, negative 3 over 2, so positive 3 over 2. Don't forget the A coefficient when you're applying Vieta's formula. Alright, so part A asks us to find a cubic equation with roots alpha squared, beta squared, gamma squared. So we can go ahead and use our substitution, and I guess the easiest way is to chuck all the even powers on one side and the odd powers on the other, and then square both sides. So 2x cubed plus 2x is equal to x squared plus 3. And then observe that since there's only odd powers on this side and even powers on this side, and an odd number plus an odd number makes an even number, and an even number plus an even number makes an even number, if we go ahead and square both sides, we're going to have only even powers of x in our equation, and also they're going to be twice as big. So squaring both sides, squared, we get 4 times x to the power of 6 plus, and then 2 times the product of these ones, so 2 times 4, so 8 x to the power of 4, and then plus 4x squared, and that's on the left side. On the other side it's x to the power of 4 plus 6x squared, and then plus 9. And since alpha, beta, and gamma all solve this equation, so roots alpha, beta, and gamma, we have, for example, 4 times alpha to the power of 6, which is the same as alpha squared cubed, plus 8 times alpha squared plus 4 times alpha squared is equal to alpha squared plus 6 times alpha squared plus 9. And so alpha squared is a root of this equation here. And so then we make our substitution. So 4z cubed plus 8z squared plus 4z equals z squared plus 6z plus 9. And then rearranging it to make it look nice. 4z cubed, how many z squareds do we have? Plus 7z squared, and then 4z minus 6z, so minus 2z, and then minus 9 equals 0, and well, this has roots alpha squared, beta squared, and gamma squared, since we literally made the substitution z equals, well, alpha squared here, but it doesn't matter whether we write alpha, beta, or gamma in this green line. For part B, I think there's a few ways you can go about it. I guess you could do exactly the same thing that we just did and get a polynomial that has roots alpha to the 4, beta to the 4, and gamma to the 4, and then just check what is the coefficient of z squared in that new polynomial. But I think maybe it's faster to do just a bit of algebra here let's let A equal alpha squared, B equal beta squared, and C equal gamma squared. Then we know that A plus B plus C is equal to, A plus B plus C squared is equal to A squared plus B squared plus C squared plus the sum of AB, which is, well, you know what it means by now. Now we know A plus B plus C, which we would always write as the sum of A in our usual notation. So the sum of A is just negative 7 divided by 4. So we got negative 7 divided by 4 squared, because that's the negative B divided by A in our polynomial with the roots A, B, and C. And so that is equal to the thing we're looking for, sum of A squared, plus 2 times the sum of AB. And we know the sum of AB is equal to C divided by A. So that would be negative 2 divided by 4. So, whoops, I forgot a 2 here. My mistake. 2 times the sum of AB. Okay, so the sum of A squared plus 2 times, and then it will be negative 2 divided by 4, which is negative a half. Okay, so that means that the sum of A squared is equal to 49 over 16 plus 1. So that is 65 over 16. And of course, A squared plus B squared plus C squared, which I've written as the sum of A squared, is alpha squared squared plus beta squared squared plus gamma squared squared. So that is alpha to the 4 plus beta to the 4 plus gamma to the 4, which is what we were looking for in part B.